His middle name is David. He's not related to the actual David Beckham, much to his dismay. Sam is a front-end web developer at GitLab. He's also the co-organizer of Front-End NE in Newcastle. Sam is the one that gave us the ticket to give away 2 months ago?
I don't know, it's on the blur.
At some point. So we also have both speakers this month are organisers of other events. I've been trying to get Sam to talk for a while, and I'm glad that he's finally here. He came with Jamie in January and basically said, I'll speak if Jamie speaks. So this is why we've got both of them this month. And Sam's going to be talking about making GitLab a PWA. So take it away, Sam. Thank you very much.
Cool. Thank you, Luke. My first, I sound like a robot. My first 3 slides are all in production, which Luke has just totally done for me, which is awesome. I am here to talk about making GitLab a PWA, or how I learned to stop worrying and embrace the boring solution. Now, I'm not going to do questions at the end of this because I don't like doing that in front of people. It's a bit strange, and So, I'm at Sanity Beckham on Twitter. Tweet me your questions, and I'll answer them much better than I ever could up here. So, if you haven't guessed, I work for GitLab. If you don't know what GitLab is it's like an application for the entire DevOps toolchain. So it's a bit like GitHub, but with extra features, like you've got your CI, you've got security scanning features. We call pull requests, merge requests, because it's a much better name for them. And all sorts of daft little bits and pieces. This isn't a shameless plug. This will make sense a little bit further on. I'm directly going to talk about GitLab. As Luke also said, I do organise a meetup in Newcastle called Front-End NE. Very, very similar to this one. We meet on the first Thursday of every month. And after about 3 years, we were so successful that we decided to run our first conference. And then about last month, we did the second version of that conference. So we're thinking of doing like an every April annual conference. So I want to start off this actual talk with a little bit of a story, and that is about the website for the 2018 version of our conference. Now, conferences and conference Wi-Fi is notoriously bad, and they're notoriously slow Wi-Fi speeds. So I wanted to make sure that this website, it worked. It loaded really quickly offline. It loaded really quickly on bad internet connections and on spotty Wi-Fi when things are dropping in and out, and the speeds aren't great. So I wanted to make sure that was as good of an experience for everyone as possible. So I started off with a few benchmarks, and I looked at Wi-Fi. Wi-Fi speeds just being generally fast internet. Don't look too far into this. And it loaded in about 1 second, which it's not bad. It's not bad. 3G is a better benchmark, and it's more likely the speeds people are going to be getting at the conference itself. So when they're trying to load things like the schedule, or trying to find out what time lunch is, or things like that, we should be getting quick speeds on this so that they can get on with the day and do what they need to do. And we were getting about 3-second loading speeds, which it's not bad. It's not bad, but we can do better. And I did exactly that. I went away, I added about 100 lines of JavaScript, and a couple of other little tweaks, and I managed to get 300% speed increase on the Wi-Fi and get it down to about 0.3 seconds loading speed, which, according to Wikipedia, it takes 350 milliseconds to blink, so this is literally loading in the blink of an eye, which is a really good thing to be able to say. 3G, given that there's a 300% speed increase on Wi-Fi, we'd probably expect about loading speeds of a second. In fact, we're getting 0.3 seconds on 3G as well, which again, in the blink of an eye. And all of this, the speeds, they don't really matter. It could be Wi-Fi, 4G, 3G, 2G, Gina G, Ali G, doesn't matter. Because when you're offline, the website loads anyway in about 0.3 seconds. So we don't get the Chrome dinosaur anymore, unfortunately. You do get our website. And all of this is because I turned that website into a PWA, or a progressive web app. This is a bit of a strange term, it confuses a lot of people. The conference website is not a web app as in a single page app or a React app or anything, it's just a static website. But progressive web app is the term that we use. I prefer this phrase, but it's not quite as catchy. It's a website that acts and behaves like a native app. So you can do various things that you wouldn't normally be able to do with a website. Things like installing it to your home screen and push notifications and things like that. The one that helped us with the offline support is being able to install it to your device. Now this is installing it to your device, it's not just adding it to your home screen like you can with any website. All that is a bookmark that opens Safari at the right page. This actually lets you install the website to your device, so it downloads files and puts them on your device. So if you think of it like a game on your PC or your PlayStation or whatever, you have to download the game onto that device so that you can then play it either online or offline, it doesn't matter. And this is exactly what we want to do with our website so that we can load it offline. The best thing about this though is that it is a progressive enhancement. So if your device or your browser or whatever don't support service workers, which is the main driving force behind PWAs, it doesn't matter. You still get the website, it's still just a website. You don't lose anything because you don't have this functionality. So if they support it, great, you can get that offline support, you can get really quick loading speeds, you can get all the other bells and whistles that come with a progressive web app. But if you don't support it, it's just a website. So, that out of the way, when I started at GitLab, I thought, okay, all these little progressive web app talks I've seen, they give some small apps and some examples of how to convert an emoji chat app to a PWA or something like a conference website to a PWA, and they're all really small static sites. GitLab is certainly not a really small static site, it's massive. So I gave myself the challenge of converting GitLab into a PWA. And the reason it's not quite as straightforward is if we look at, so this is a merge request page on GitLab, you see that if we were to just cache this and just serve this straight up to the user as it was when they first visited the page, all sorts of things would be out of date. So if you look, you've got like the number of merge requests on a project, the number of issues on a project, who's commented on a project, the comments on a project, the pipeline, the current status of the pipeline. You've got your issues, your merge requests. There's all sorts of things here that are changing all the time. So we can't realistically cache the entire page and then serve them that. We can't install that page to their device. So we have a concept at GitLab that we call the boring solution. It's not a novel concept in any way, but it really does help us think about how to get things done quickly and move forward very quickly and get features in that normally you wouldn't, because you overthink things and you look at something like this and go, well, that's too complicated, let's just leave it. The boring solution is basically what is the smallest iteration of something that we can do to get started on the right path. Not necessarily ship the actual feature or even ship the minimum viable version of the feature, just what is the smallest step we can do to get us on the right path. So bear that in mind, and we will come back to that. I'm going to use a program here called Lighthouse to just do a quick check of GitLab.com as it is currently and see where we are on the steps of making GitLab a PWA. So you can do this on any website. Lighthouse is built into Chrome DevTools. There's also a website for it and a browser extension and all sorts, but you're best off just looking in Chrome DevTools. So if you go into Chrome DevTools and you go over to the Audits tab, which is way on the right, I don't know why that's confusing me, it's exactly the same as it is when I'm looking at it. Yeah, you should see an audit for Lighthouse on there. And I ran this on GitLab.com, just on my profile, and you can sort of see there that there's two lists of things. There's a list of things that we've already passed, and there is a list of things that we still need to do. And this is before I've done anything, and you can kind of see that I've already done most of the things without ever actually doing anything. This is a more slide-friendly version of this list, so I'll just quickly go over the things that we've already done, and they're mainly best practice stuff, so most websites should have these done anyway. Non-JavaScript content is the first one. Does your website load something when JavaScript is disabled? It really, really should. Like just something, even if the page just says, please turn JavaScript on, you don't do that, but this will pass this. HTTPS and the HTTPS redirect, again, pretty straightforward. You're serving your website over HTTPS, and if someone tries to go to the HTTP version of it, do we redirect them to the HTTPS one? Fast enough on 3G. Fast enough is, does the website load within 10 seconds? Again, it probably should. If it doesn't, you've got bigger issues than progressive web apps. Is this cutting in and out all the time for everyone? Shall I don't know what to do. I'm just going to carry on. Right. Where was that? Yeah, that might be easier actually. Well, that just no swap.
Yeah.
Okay.
Is there different channels? Just flick these on off.
Well, no, I constantly sound like a robot. This is a marginal improvement. Right, yeah, so fast enough on 3G. Does it load within 10 seconds? It should. If it does, you get the green tick. If not, there's plenty of tips and tricks that this, I'm cursed. This same audit, it'll tell you and it'll help you through these things. Meta viewport tag. Now this is a thing where when you make a nice new responsive website and you don't use a boilerplate or anything, this is what, where am I? Yes, you make a nice new responsive website, you don't use a boilerplate or anything, and it looks all nice, and then you look at it on your phone and you go, oh, everything's zoomed out. This is the tag that you forgot to put in your head, you know, the one that says meta viewport scale width, the one you copy and paste all the time. This makes sure that that's in there. Size for the viewport, again, it's a responsive thing. It's a fancy way of saying, is your website responsive? So again, best practices, we should be doing these now. It's 2019. If your website's not responsive, you shouldn't be worried about PWAs. You should be worried about making your website responsive. So, let's go on to the things that are a little bit less commonplace and the things that we need to actually do to make GitLab or any other website a PWA. Custom splash screen is the first one. So, what is a splash screen? This is a splash screen. It's that little screen that you get before Twitter opens or Facebook opens or Candy Crush or whatever other apps you want to open. And they're relatively easy to do. It's handled in the same way that we handle the themed address bar, which is the next point on the list. This is weird. I don't really know why this is a prerequisite for PWAs. Basically what this is can you change the color of the address bar for no reason at all, specifically on Chrome, specifically on Android. Luckily, it's really easy. These screenshots are like 5 years old or something. I should really update these. So both of these things, the custom splash screen and the themed address bar, they're both achievable with, put that down, achievable with this manifest.json file. So this is basically just a JSON file with some simple properties like the name of the app and the short name of the app. They are both GitLab here because there's different character limits on the two and they use different ones in different places, but GitLab being 6 characters, it's not hitting any character limits anytime soon. Display standalone, this says when I open the progressive web app on my phone, I don't want to see the browser Chrome. Not the Chrome browser, but the browser Chrome, so the address bar, the back button, all that sort of thing. It makes it look and feel a little bit more like an app. Scope, I will get to later. Start URL, this is saying what page do I want the app to open at when I open the app. So most of the time, just set this as the root, and your routing will deal with whether you need to go to the login page or whatever it is. I've never found an instance where you need to send this to a different page, but you can if you want to. Theme color. This is what changes the color of the address bar that we're about to hide with the display standalone. Completely pointless, but we need it. Background color and icons. So in order to generate the splash screen, Chrome and whatever browser will do this for you by taking the background color and then putting an icon on top of that background color and just making you a nice, quick and easy custom splash screen. So if you think back to the Twitter one, it would just be a background color of blue with an icon of the Twitter logo. And them icons as well, they're also the icons that are used to generate the little app icon on your home screen. So nice and simple. 2 things ticked off the list there. Generate this manifest.json file and then just include it in the head of your web page, same as you would a CSS file or something else. Just set the rel to manifest and then the href to wherever your manifest.json file lives. So we're already halfway through the list of things that we were already halfway through, so you might say we're 3/4 of the way through. Yeah, 3 things left to do. Service worker, 200 when offline, I'm prompted to install the web app. So service worker, this is the big thing. This is the driving force behind it. This is the 100 lines of JavaScript I was talking about. And it's a new-ish concept. It's really, really powerful, but really simple in its general idea. And in order to explain what this does, I've got to go back a little bit and sort of explain how general websites work, really. This is really simplified and maybe a little bit patronizing, but bear with me. A browser makes a request to the server and the server responds with something. So the browser can request an image and the server will respond with that image and send it back to the browser. Or the browser can request a page and the server will do whatever it needs to do to build that page, if there's some template in or if it needs to check if you're logged in or whatever, and then it responds with that page to the browser. What a service worker does is it sits in the middle of these requests and these responses. So it can listen to any request, it can modify it before sending it to the server or just pass it through, and the same with the responses. It can listen into all of them, do something else with it, modify it, and then send it back through the browser. And this is relatively simple, but it can do some really cool things. So as a really, really simple example, when the browser requests catpicture.png, the service worker hears that request, and it can just pass it straight through to the server. So it's now asking the server for the cat picture in the same way as if the browser was just passing it normally. And then the server responds with its cat picture, and the service worker can just send it back to the browser. As far as the browser is concerned, it's asked for a cat picture, it's received one. As far as the server is concerned, it was asked to give a cat picture, and it responded with one. So everyone's happy. The service worker is just listening in on the middle, and it's just listening in to these requests. And because it's listening in, when it gets that picture of the cat, the picture of the cat, it can put it in its own cache. So that next time, when the browser requests the cat picture, the service worker can ask the cache, do you have that cat picture that I gave you earlier? And then the cache can return the cat picture, and the service worker can return that to the browser. Now the browser, the service worker, and the cache are all client-side. They all live in the browser, so these requests are super, super quick, which is why we were getting the really quick loading speeds on the conference website, because everything was cached locally. And also, the server has no clue any of this is going on. So if you're offline, it doesn't matter, because we're just making the requests directly from the cache. Now, this is quite a simple example, and it's at this point a lot of people think, well, you can kind of do this with regular HTTP caching. Why are you going to this effort? And you're right, you're totally right, but you can do a little bit more with service workers, and we'll get to that in a minute. But what do we need the service worker to do for us? We need it to help us tick this box in Lighthouse. We need to get a 200 when offline. 200 when offline. 200 is a status code, the HTTP status code that just says everything's fine, everything's good. So when we're offline, we want to receive something that says everything's good. So in the conference website example, that was the conference website when you requested it. even when you were offline. I've already said, in GitLab's example, we can't really do that. We can't go offline and just send somebody the cached version of something because it will be wrong. Everything will be out of date, and it wouldn't be a good experience if you were to implement it as we did on the conference website. So what's the boring solution here? What's the smallest change we can get that gets us on the way to making GitLab a PWA and getting into... I should say there's solutions to this. We can do this with a service worker, and we can have parts of the page cached and parts of the page not cached, and we can have it update certain parts of the page on the fly and do all sorts of clever things with it, but it'll take a long time. We need to find the boring solution that gets us towards that goal, that gets us sort of on the right path to doing this. So if we look back at this, 200 went offline, this is what we need to do, but this doesn't actually say, give me what I've actually asked for when we're offline. This just says, give me a 200 when we're offline. So, I shouldn't have put that in twice. What we can actually do is, instead of returning what they've actually asked for, we can return this page, which is just a nice offline page that says, you don't have an internet connection, looks like your internet's off, maybe you're just going through a tunnel. You know, we're adding offline support to GitLab. It's coming in a future release. So this satisfies that 200 when offline because you're receiving something even when you're offline. It's kind of helpful to the user. It's not as helpful as the whole thing being offline, but it's a step in the right direction. And it ticks that box on the Lighthouse tests to get us the PWA status. So how do we do this? As I said before, the service worker is a little bit smarter than HTTP caching. So what it can actually do is, as soon as you load any page and the service worker kicks in, it can ask the server for that offline page. And the server, as far as it's concerned, it's just received a request for the offline page. It doesn't need to know that the browser specifically hasn't requested it. So the server responds with that offline.html. And then the service worker can just put that in the cache and save it for later. So later on, when the browser requests an issue page, the service worker passes that request straight onto the server. If it's successful, it just sends it back to the browser. The user's none the wiser. It doesn't matter. It's just listening into the request and passing the successes right back through the browser. But in the instance that network connection is not there and the user is offline, the service worker's planned for this, and it can say, okay, I know what I'm doing. I'm going to ask the cache for that offline page that I had before, and the cache responds with the offline page, and the service worker responds with the offline page to the browser. So when you're offline and you request the issue page, merge request page, whatever page, unfortunately you don't see the dinosaur anymore. The dinosaurs are now extinct again. So this is all well and good on a sort of flowchart thing. It's probably quite complicated to do in code. It's not really, it's really easy. This is how you do it. It's not all of it, don't worry, it's not 5 lines of code, I'm not mental. First thing you need to do in your regular JavaScript file, you need to register the service worker. So we just say if service worker in Navigator, which just means does the browser currently support the service worker? Again, if it doesn't matter, you've still got the website. If it does, happy days. We tell it to register the service worker, and we tell it where the service worker is and the scope, which is what files and what routes the service worker can affect. So, little caveat here, the service worker does need to live in the root directory, so it needs to be right at the top level, because for security reasons, the service worker can only affect requests made to either the same directory it's in or directories below it. So if you put your service worker in assets JavaScript, it could only intercept requests made to assets JavaScript whatever. It couldn't help with any requests to images or routes outside of the assets folder. Long story short, put it in the root. So this is the service worker itself. This is the service worker we registered in the previous one. It's a separate file. And service workers work by listening into certain events. So like the component lifecycle events in React or Vue, where you've got the component will mount or mounted or all them different things. The service worker has its own versions of these, and the first one we want to listen to is the install event. So we just add an event listener for this install event, and this is just as soon as this registration happens, it hits the service worker, and the first thing it does is install itself. So what we want to do is we want to open up a cache, and we've named it up here, current cache. Don't name it 3 dots, that's a terrible idea. The GitLab one is named the current version of GitLab, and then it's appended with the current hash, because I really, really don't want old caches sticking around, because that can cause a lot of problems. Building in named caches and cache busting from the beginning is something that I really wanted to do. So this goes away, it opens that current cache, and then it just says, okay, in that cache, add the offline page. And this handles the fetch stuff for us, so this will fetch the offline page from the server and just store the response in our cache. Nice and easy. Activate. This step I didn't actually include on the flowchart, but this is just a little bit of cleanup for the cache busting stuff. So it looks a little bit complicated, but if you kind of drill into it, it starts to make sense. We just open up all of the caches that we have for our website, and if the name of any of them caches don't match the name of the current cache in this file, delete them. It's an old cache, we don't want it anymore. It just stops old caches lying around. So this is on the activate event. This happens as soon as the service worker itself is activated, so after it's installed. So again, if you go back to the PlayStation analogy, you install a game to your PlayStation, and then when you open it, that's essentially activating it. So it's after it's installed, but while it's running, sort of thing. And then this bit here, despite being the smallest bit, is actually the bit that does all of the nice offline work. And we just say, okay, listen into any fetch request. So this is any request made from the browser to the server. And instead of just letting that go through, we hijack it. We take the request itself, so all the request data, and we create our own request with that exact same data, and we send that up to the server. If it's successful, we don't really do anything, we just hand it straight back as is. So you could do a then here, and you could do something with the response if you wanted to. We don't want to do that, we just want to pass it back as normal. What we do want to do is we want to catch any of them errors, because them errors happen when we're offline. So we catch that error, and we respond with the offline page that's in our caches. So we just look in our caches for the offline page, and we respond with that. So nice and simple, really. This is the entire service worker. I can fit it on a slide, and it, you know what I mean. It does quite a bit, and it's a very small amount of code. So if we go back to Lighthouse, we've done basically everything now. We ticked off the service worker box by adding that service worker. You can tick that off by adding an empty service worker that does nothing, but the service worker we added actually gives us 200 when offline, so we've ticked both of them off. Happy days. We did the themed address bar and the custom splash screen with the manifest file. And we've only got one thing left to do, and that is prompted to install the web app. I've truncated this a little bit and realised it doesn't quite make as much sense as it should. So is the user prompted to install the web app? So what this means is when the user's going around your website, after they've been on it for a little while, are they prompted to add that to their home screen and install it as a web app? Now I've tried to fit how to do this on one slide. It's a little tricky, obviously, but just bear with me. What you need to do is fuck all. Yeah, so Chrome and whatever browser it is you're using handles this for you. It knows. I don't know how it works it out. Probably machine learning. Everything's machine learning now. It works out the intent of the user, and if they've been engaged on your website for a while, and it will actually just prompt them to say, hey, do you want to install this web app? You look like you're interested in the website. And the benefit of this is BuzzFeed can't just like spam that at you, because Chrome are in control of it, not them. Yeah, so
Lighthouse, all done. Everything ticked. We now have a fully fledged PWA on GitLab or whatever else it is you were doing. And that looks like this. Oh, autoplay worked. So if I go offline and try and load it locally, we get the Chrome dinosaur. That's because I've not actually loaded the site. You can see we've got no service workers here yet. If I go back online and then load GitLab, you can see it's the DevTools is balked a little bit here, but we do actually install the service worker. It's just down here, and that's activated and it's running. So now when I go offline again, we get the offline page instead of the little Chrome dinosaur. So that's all up and running and working. That's pretty nice. Yeah, that's just a looping video now. My Android device actually broke while I was preparing this talk, so I don't have any screenshots of being able to install it on a device, which is a shame. If anyone has an Android device that I could borrow some screenshots of later on, come find me. But Chrome have actually, behind a feature flag in the desktop version, allowed progressive web apps to be used on desktop. Now it is behind a feature flag, so there's still little niggles like despite me saying hide the browser Chrome, it's still kind of a little bit there. But if you look over in the corner, there's a teeny tiny tanuki, which is often called a fox, which it is not. GitLab logo, because it's an actual app. So if you go in your applications folder on your Mac, it's a proper app. It's just a wrapper for the website because it is just the website. But being a progressive web app allows us to kind of get some appy type stuff in there. Gotchas. I made it sound pretty simple, didn't I? It's never as simple as you make it sound in a talk. And most of these issues were caught by CI/CD. This is not a dodgy rock tribute band. This is continuous integration and continuous deployment, which is something that's built into GitLab. If you're not entirely sure what this is, red crosses are bad. We don't want red crosses. It's just a way of running tests and linters and things to make sure that the code that we're pushing to the master version of GitLab doesn't break the master version of GitLab, which on my first try this definitely will have done. Luckily this falls down to one or two things that can be relatively easily fixed. The first one, naming clashes. This was something that made me chuckle when I finally realised what was going on. So if you remember back when but it was 5 minutes ago, of course you remember. This is our offline page, and it was at, well, localhost because we were developing locally /offline, which is fine. When we go to gitlab.com and push it there, it will be at gitlab.com/offline. If you go to gitlab.com/offline, you'll see Andrew's profile, because Andrew's username is offline. Thank you, Andrew. So yeah, gitlab.com/offline is it's a no-go. We can't do that. But there's a simple fix. We just, instead of having the offline page /offline, we just have it at sort of offline. I like to think of that as a little man going, get out the room. Just moving it over a little bit. So that's an easy fix. We just move that to /offline and we keep it there. Request types. This was the big one. This is what was causing the majority of the failures. So the service worker, when I said it listens into all of the requests and the responses and things, it's actually quite greedy, and it does listen into all the requests and responses, including post requests and put requests and push requests. I think I might have just made that one up. Yeah, so it listens into all the requests, and we don't really want it to. So all we do is, inside our service worker, we just add these bits here that says, look, we're only interested in get requests because we only want to show the offline page if they're trying to get the offline page. We don't care if you're trying to post anything. And furthermore, we only care if the request mode is navigate. So that means if you're requesting a page as opposed to a JavaScript file or an image or whatever, because again, we're only showing the offline page. We're not interested in, at the moment, we're not interested in caching things like the JavaScript or the CSS. We will do in further iterations, but for the sake of this, we just want the navigation requests. So doing these two things actually turned our CI pipeline from a lovely shade of red to a lovely shade of green. Green is good, green is passing, green means I can actually get it merged in, provided I convince the back-end engineers that this is totally a good thing to do. Hopefully I will have done that by version 12 on June the 22nd. The previous time I gave this talk in Middlesbrough, it said April 22nd, which was 3 days ago. That didn't happen. Yeah, so it turns out the hardest part of making your website a progressive web app is not actually making it a progressive web app, but convincing people that this is definitely the right thing to do. Yeah, so hopefully in this version we should have basic PWA support, which gives you the offline page, and I've already started working on vulnerability caching. So vulnerabilities, I work for the security team on GitLab, and we do security scanning. So we'll scan your code base for vulnerabilities and provide a list of them vulnerabilities so that you can look through them and action them and do all sorts of things with them. But it's quite slow. So what this aims to do is when you go on that page, if you've previously been on it, it'll first serve all the vulnerabilities that you had previously, and then in the background it'll make a fetch request for the most up-to-date list, and then when that returns it'll populate that list or update that list with the most up-to-date ones. So it's like a sort of more helpful skeleton loader. So hopefully these will be in by version 12. If you want to follow along, GitLab is completely open source. The merge request for the progressive web app is here. The issue for that discussion caching, the vulnerability caching that I was talking about is here. I will share the slides, but they are available at that link if you want to grab them. Thank you very much.
Okay, so that's not working. Great. Cool. Thank you very much, Sam. So this was totally unplanned that both these talks were going to be PWAs and generated sites. But if I can get this switched over, so we have a new site because we're now going to be using Meetup, and this needs to swap over. Come on, please swap over. Please? Something crashed.